We are going to go over some of the transformation operators which are there in Spring Web Flux. Before going over them, let's first try to understand what a transformation operator is. So, till now, we got to learn about the creational operators, which helped us create publishers that emit some data, right? But what if you emit the data, like a publisher emits the data, and in the downstream, somewhere you want to do some kind of transformation? Then how will you do that? That's where the transformation operators help a lot. You can transform your data in the reactive chain, and then in the downstream, the transform data will start flowing. So as we go through this, you'll understand what I'm trying to say right now. Okay, so let's start with it. Let's just start with the map operator. Uh, Now, some of you might have used the map operator in JavaScript. How it works is there is an array which contains some sort of data. You apply the map operator, and from the map operator, you return some transform data. And now, as a result, you get a resultant array which has the transform data. So here also the map is similar to how the map in JavaScript works. You can return some transform data, and then onwards in the downstream of your reactive chain, the transform data will start flowing instead of the actual data, instead of the original data. So let's first understand this through a code example. So I have a test here for map. Uh, let's create a publisher first of all. So we'll create a mono publisher which returns some integer, and then we want to apply the map operator. Here you'll get the data that was emitted from upstream inside this consumer function. So you got the it is actually 5. Okay, and from here you want to return 8 multiplied by 2. You want to multiply it by 2, and you want to send it downstream, and then we'll subscribe to it. Okay, we'll get the on next signal here. We'll just print it out. Okay. Okay. Now if we run this, instead of 5 we'll get 10, because we transform the data over here, and now in the downstream the transform data has started flowing. So if I run this, and we can see we got on next as 10. Okay, just give me a second. I'll just increase the font a bit. Okay, now I think it should be visible to you. Yeah, so we saw the data got transformed, and now we are getting 10 in the downstream. So that's how the transformation operator works. Now there is one more thing. You can return any sort of data from this transformation consumer function. You don't have to return an integer. Just that from the upstream, if you are getting an integer, you're not restricted that you should return integer only from your transformation consumer function. You can return any sort of data in the downstream if you want. Okay, so we can just see an example. So suppose we want to return a string from here, we can do that as well. Is the number, I'll see. Okay, and if we run this, this also runs perfectly fine, and we get the output as 5 is the number, right, which is a string, it's not a integer. So yeah, you can return any sort of data from within the reactive chain, like using these transformation operators. So the chain started here, it was emitting an integer, but over here we transformed it to a string, and now in the downstream, instead of an integer, the string will start flowing. Okay, so that's how map operator works. This is how any sort of intermediary operator works. Whatever you return from that operator will then start flowing in the downstream, unless it is an operator which is just which just is introduced for the side effect. If you want to do the side effect, you don't want to impact your stream data, like that is flowing through your reactive chain. So those are different operators. We'll go through them also later on, but currently whatever all these operators which are here, the transformation operators, they actually affect your downstream data. They change the data which is flowing through the stream. Alright, so that's about map. Now that you understand map, you'll understand flat map also easily. Now the key difference between map and flat map is, from the map you can see we returned a value. Okay, you can return any sort of value from here. Okay, but from a flat map you have to return a mono publisher. You can't return any other value other than mono publisher. You have to return a mono publisher. All right, you can return a mono publisher which emits any sort of value, that is allowed, but it has to be a mono publisher. Okay, so if I show this example quickly, I take this only, and instead of map, now if I use flat map, it will give us the error, right? It says key no instance of type variable r exists so that string conforms to mono of extends r. So basically it is telling us key it has to return a mono publisher. So if you want to get rid of this error, we will just return a mono publisher which returns this data. Okay, if we do this, the error is gone, and now if we run this, should work perfectly fine, right? 5 is the number we got. So basically that is the key difference. From a flat map you have to return a mono. From map you can return anything. You can actually return a mono also from a flat map, from a map. So if we try to return a mono right from here, it will not give any error to you and it will run just perfectly fine. Right, we got a mono, just it is not a result, that's why we got it like this, right? So that's the key difference. Just understand that difference, and this difference is there in the upcoming operators also between filter and filter one. We'll come to that. Okay, now if we think about the usages of flat map, right? Map to be understand, we can do the transformation. In case of flat map, why would I want to return a publisher? Why would I even want to use flat map, right, if I have map? So basically, you can imagine, suppose there is this API call, some API call has been made, and then you want to make another API call which returns some data, and then you want to operate on that data. So some data is coming from this API call which is needed to make this particular API call, and when you want to make this API call and you want to make flow the result of that API call, the result of that API call in the downstream, right? In this case, you can use flat map, right? Because that API call will be returning a publisher in the Spring Web Flux sense. All right, it won't be a it won't be a blocking operation. It will be a reactive operation. So what that implies, that the API call will be returning a publisher. All right, and in those cases, flat map comes in very handy, and you'll be mostly using it. Flat map and map both together you'll be using. Yeah, so that's the difference between map and flat map, and that's how these two operators work. We'll move on to the next one, which is filter. Now from the name itself you might have guessed what it does. If you want to filter the data based on certain conditions, you want to enable it or disable it to flow through the downstream, you can use this filter operator. So what I mean by that, we'll just understand through an example. So we created a publisher, we added a filter function, and here we will say if it is exactly equal to 5, then only flow it through the downstream. So we'll have a subscribe, and we'll just print the whatever that is flowing over here in the downstream. Right, so if I run this, we got the on next file, right? But if we change this to something like this, if it is exactly equal to 1, then what happens? Right, we did not get that on next signal itself, right? That means the data, the chain stopped here only. It did not flow any data in the downstream, since this filter has filled, the filter predicate that whatever we have given has filled, right? So yeah, that's how filter works. Again, obvious use cases. Some data is flowing from the upstream and you want to filter only some part of it, you can use filter, right? And now comes the filter when. Filter when, again, like map and flat map, there is that difference, right? It is similar. From filter when, you can return a publisher. So here the predicate is actually a normal non-publisher thing, right? Just a normal operation. But from the filter one, you can actually return a publisher, right? So if I just copy this example over here, and instead of filter, if we try to use filter when, right, it starts failing and gives the same error, that boolean cannot be converted to publisher of boolean, right? So you have to actually make it like mono dot just it exactly equal to 1, and then it will just work fine. It just works similar to filter. Okay, I won't run it, although I'll just run it once. Yeah. So we did not get any result, and if we make it 5, we'll get the on next signal, right? So it works exactly similar to that of filter. The only difference is you can return a publisher. Again, the use case here is, suppose you want to make the decision based on certain async operation. So basically you got some data, and then you want to make some API call and passing that data in the request body, and that API call's response will tell you whether to whether to continue with the reactive chain, whether to flow this data in the downstream or not. If that is the scenario, then filter when comes in very handy in that case, right? So whatever async operation that you want to do, you can do it easily over here, and filter when will make sure that that async operations result is resolved, and then it is flown in the downstream, right? Yeah, understood filter and filter when. We saw one thing, which is when the upstream was returning mono empty, we were not getting any signal. In subscribe, we did not get the on next print log. So what if you want to return some default data if the upstream returns a mono empty? That's where the switchIfEmpty operator comes into picture. How that works is, I'll just show you how that works. Okay, I'll just copy this and paste it over here, and then what we'll do, we'll add a switchIfEmpty over here, and from here you have to return a mono. So you can return a mono.just whatever data that you want to, default data, right? So over here upstream was returning 5, this predicate failed, and now it will go to switchIfEmpty, and whatever default data that it is returning, it will return in the it will pass it down in the downstream. So if I run this, obviously we should get on next 0, right? And that's what we got over here. So that's the purpose of switchIfEmpty. There is another operator which is defaultIfEmpty, which does the exact same thing as switchIfEmpty. The only difference is that from defaultIfEmpty, you can return anything. Like, it doesn't have to be a mono, right? Okay, you can't return a mono, sorry. You have to return some value, like some data. Okay. So and another thing over here is we have to return the same kind of data which is flowing in the upstream. So if we see here, right, it asks us to return an integer. We cannot return a string from here. Okay. So if I return 0 and run this, then it works in the similar way as switchIfEmpty does. Alright, and as we saw, right, it has to return the same data that is published by the upstream. So let's just validate that. Okay, if I'm returning something and it has to be equal to empty, which it is not, so it will come to defaultIfEmpty, and now we can return a string from defaultIfEmpty. So yeah, that's how it works. Whatever kind of data the upstream is publishing, the same kind of data defaultIfEmpty should also publish. Let's check that one more time. Yeah, so we got default. Now let's just validate this for switchIfEmpty also. I'm also not sure that switchIfEmpty also works in similar fashion. So if I try to return a string, yeah, it fails. So switch if empty also works in that way. It has to return the kind of data, the type of data which is being published by the upstream, right? uh, so many a times you'll be using filter when and switch if empty together, right? So uh, you might come across writing such code. Okay, what you'll be writing is dot map, and then you'll be getting it, and here you'll be saying that if it exactly equal to empty. What happened here? Okay, sorry. Yep. If it exactly equal to empty, then we want to return a string like called empty. Okay, and if else we want to return whatever that is coming from upstream. All right, so if we run this, right, we'll get something, correct? Oh, sorry. Let me just get rid of this error. Okay, now let me run this. Yeah, so we got something because it is not empty, and if I return empty, we should get empty as a string in the on next signal, right? Now you might be writing such code, okay, often when you're writing some logic for your application, and you can avoid this if condition by using the filter operator. If you want to write the code in very reactive fashion, like you want to use all the reactive operators out there and don't want to write such logic, then you can use filter and switch if empty, right? So the same code you can write using filter and switch if empty, like which returns the same kind of like which behaves in the similar fashion. So what we want to do is we want to first filter it, and it should not be equal to empty, right? And if it is empty, then we want to return empty as a string, right? Then you don't have to write this map, and it will just work in similar fashion. So I just comment this out and run this. Yeah, so it is empty, and filter is if it is not equal to empty, then flow the data into the downstream, otherwise return mono empty. So in this case it will be an empty signal, so it will go to default if empty and we'll get empty as the value, right? And if we return some value which is not empty, then we'll get something, right? Because this filter will be it will pass, it won't go to default if empty, it will directly pass whatever data is coming from upstream to the downstream, and that's why we are getting something, right? And yeah, so same code you are written in two different fashion, both are correct, it's just up to you. If you want to write code more reactive, like if that's your thing, you can do it like this, else it's perfectly fine, you can use this as well, there's nothing wrong with that, right? So yeah, these are some of the operators that I wanted to cover as part of this particular video, and these are the most commonly used operators whenever you are writing your application code, you'll be mostly using these operators. Now there are some other operators as well which we'll be covering in the upcoming videos. I hope this video was useful, and let's see you in the next one. Bye.